Hi, in this video I'm going to install a Ceph cluster using Ceph and connect the external cluster to Kubernetes using Rook. Rook is the recommended method to connect an existing Ceph storage cluster to Kubernetes. Note that this is a demo video. To make your Ceph cluster production ready, follow the hardware recommendations on the official website. Let's talk a little bit about Ceph architecture. What is Ceph? Ceph is a clustered and distributed storage manager. That means that the data that is stored and the infrastructure that supports it is spread across multiple machines and is not centralized in a single machine. Ceph offers three storage interfaces: Ceph File System or CephFS, RAIDers Block Devices or RBD, Reliable Autonomic Distributed Object Store or RAIDers. Each interface requires specific components to run. For example, if you want to run CephFS, you have to install a metadata server or MDS. In the video, I am going to use the RBD interface. We have to install three components to use Ceph with the RBD interface: Ceph Monitor, Ceph Manager, Ceph OSD daemon. The Ceph Monitor maintains the map of the state of the cluster. The Ceph Object Storage daemon interacts with logical disks. The Ceph Manager daemon runs alongside Monitor daemons to provide monitoring and interfacing with external monitoring and management systems. The theory is over. Let's begin the installation. I am going to use Ceph to bootstrap a Ceph cluster. To install Ceph I am going to use a curl-based installation. The release name that we'll install is Squid. I've created my virtual machine using Vagrant. In the description, I've attached the link to the files where you'll find the Vagrant file, links to scripts and manifests used in the video. Furthermore, I've attached the link to the Telegram group where you can ask your questions. Run all commands as root. Set the Ceph release variable. Then copy the curl command and execute it. Make your Ceph file executable. To install the packages provided by the Ceph project, add the chosen release. After that, execute the Ceph install command. Confirm that Ceph is now in your path. Good. Let's install the Ceph command package, which contains the Ceph commands including Ceph and RBD. Verify versions. We are ready to bootstrap a new cluster. To do this, you just have to run the Ceph bootstrap command with the IP address of the Ceph cluster's first host. Note that if there are multiple networks and interfaces, be sure to choose one that will be accessible by any host accessing the Ceph cluster. List the IP addresses. In my case, this IP is 192.168.1.54. Execute the bootstrapping command. Bootstrapping has been completed successfully. Copy the provided information to a text file and save it. Verify that the Ceph cluster is running. In the cluster, there is one monitor, one manager, and no OSDs. The health status is a warning. The reason is that we don't have any OSDs in the cluster. Let's list the available devices to deploy OSDs. As you may have noticed, these disks were created by Vagrant during the creation of the virtual machine. Create an OSD from each block device one by one. Recheck the health status. Now the cluster health is OK. List edit OSDs. Check Ceph's OSD usage. The next step is to create a pool. A pool is a logical partition that is used to store objects. Placement groups are subsets of each logical Ceph pool. Placement groups perform the function of placing objects into OSDs. In simple terms, OSDs contain pools. Pools contain placement groups. Placement groups contain objects. Objects represent our data that was separated into blocks. That's why the core component of Ceph is named RAIDers, Reliable Autonomic Distributed Object Store. By the way, in the configuration of the pool, we can define the replicated size. For example, with the replicated size of 2, each PG will store objects on 2 OSDs, as shown on the screen. While creating the pool, we can define the number of placement groups in the pool. The Ceph cluster has an autoscaler enabled by default, which manages the number of placement groups in pools based on expected cluster and pool utilization. Autoscaling can be configured with three modes: off, on, and on. We'll disable the autoscaler and set the number of PGs in the pool manually. There's a formula that can help us calculate the placement group number for the pool. Total placement groups equal the number of OSDs multiplied by 100 divided by the pool size. By the way, there is a calculator to do this. Choose RBD and LibreADAS. The pool name is RBD. The size is 2. There are 3 OSDs. The percentage of data will be 100. Target PGs per OSD can be 100 or 200. If the cluster OSD count is not expected to increase in the foreseeable future, select 100. The suggested PG count is 128. Good. We are ready to create our pool. Open the terminal. Create a pool named RBD. Set the replicated size to 2. Disable PG autoscaling. The autoscaling is off. Set the number of placement groups to 128. Verify the pool configuration. Replicated size is 2 and the PG number is 128. We've done all the necessary configuration on the Ceph cluster. Before continuing, I recommend you read the Ceph documentation more thoroughly if you need to run a Ceph cluster in a production environment. The Ceph documentation is quite comprehensive. It's time to configure Rook in the Kubernetes cluster. Rook is an open-source cloud-native storage orchestrator providing the platform, framework, and support for Ceph storage to natively integrate with cloud-native environments. The configuration of the external Ceph cluster with Rook is pretty straightforward. Let's do it step by step. Begin by running the Python script in the Ceph cluster to have access to create the necessary users and keys. Copy the script to your node. Install pip3. Then install the dependencies of the script. Run the script with the specific arguments. Save the bash output in a text file. The next step is to deploy Rook manifests. Let's go to the console. Before continuing, you should have a Kubernetes cluster with access to it. Deploy the Rook manifests one by one. Paste the output from the rook resources.py script into your current shell to allow importing the source data. Open the import script and copy it. Paste the script. Make it executable. Run it. Verify that Rook is connected to the source Ceph cluster. The Ceph cluster has been connected successfully. Let's create a Ceph block device by deploying a stateful set. Let's add some content in the app directory where the PVC is attached and move the pod to another node. Check the node where the pod is running. It is node 2. Cordon it. Cordon disables scheduling on the node. Delete the pod and check where it will be scheduled. Now the pod is running on node 3. Let's check that the created file is still there. Everything is OK. Finally, let's find our block device in the Ceph cluster. Here it is. That's it. I hope this video was helpful to you. Don't forget to hit the like button and subscribe to the channel. See you. Goodbye.